Welcome. This is D. Sujith Kumar Reddy, and I am going to discuss about computer organization and architectures digital assignment 2. I am from VIT Vellore, Tamil Nadu. So the topic I have taken is design and implementation of low power floating point arithmetic unit, and the paper was written by Danbal R. So the first question is explain how the selected paper related to COA syllabus or curriculum. So the the floating point unit is a part of computer system specifically designed to carry out operations on floating point numbers. Typical operations are addition, subtraction, multiplication, division, and square root. This paper proposes an implementation of IEEE format point floating point multiplication, addition, and subtraction. Arithmetic on IEEE FP number imposes more challenges compared to the fixed point arithmetic. These particularly include the simultaneous computation of normalization and rounding. We show the efficient way of solving these challenges for the implementation of floating point addition, subtraction, and multiplication. The proposed design aims to reduce power distribution, hence the select paper is related to computer organization and architecture as it analyzes the floating point arithmetic unit used in a computer. So let's go to the second question. Second question, draw the existing architecture discussed in the paper using appropriate roster graph editorial software. So for the construction of a diagram, we can use creately.com. So as we previously discussed here, you can take a table and you can place it and you can choose how many divisions you want. So accordingly this you can draw a diagram. So let's see, the first one have SA, EA and MA. So by double clicking on it, S bracket A, E bracket A, and M bracket A. So the second part also contain same, but it's B part of it. So let's just say S B S B and EB MB. So here from MA to multiplier there is an arrow, and from EB to 8-bit adder. So accordingly that you can draw a line from here and narrow from here from MA to so this is how you give a diagram. And now you can insert 8-bit adder. Okay, now you can continue using the given tools in Creately to construct the complete diagram. So you can find all type of diagrams provided in there. So tripod, so you can just expand it, reduce it by whichever size you want, and you can construct the given graph. So here there are three other squares. So take another square, place it here, another square, another square, reduce size of the square, So here we can see how it works. So by this you can draw the given diagram and you can complete it by using the arrows provided here. So from here to here you can give another diagram. So by this you can complete drawing and you can export it in the given file formats. So let's get to the second question. Next question. So the third one. So draw the tabulation results and graphs using Office Suite in encapsulated PostScript file format. So let's see. This is how the graphs are represented. So the picture here you can see all the codes running it and the calculations that happening. So this is a floating point multiplication table. So this is the library area, leakage power, dynamic power, net power and times per second and power delay period. So in this you can see the floating point multiplication, high usage of dynamic power and leakage of power. So floating point multiplication and subtraction. Let's see the library typical, slow, fast, typical and slow, typical, fast, slow, high. So area, leakage power, dynamic power, net power, timing and power delay period. So you can see the difference here also. Leakage power is high as it moves on. So draw the proposed architecture discussed in the paper using diagram and vertical graph application software in encapsulated PostScript file format. So here let's go to the question number 4. So here this can also be drawn by using creately. Here you have to just go and pick circles and just insert the given data in them and you can draw it. So even the adder and subtractor also you can draw them same way. Just go there, select a table as we see for this diagram. So you can partiate it and copy it and paste it and you can continue drawing the complete diagram using the arrows provided very creatively. So let's get to the question number 5. Draw the transistor level internal diagrams using electronic schematic capture and simulation tools. Okay, transition level internal diagram. So transition level internal diagram here you can see the complete diagram of transition level internal diagram. So you can see the missing part here. That's just a resultant sign calculation and sticky bit calculation. That's the part that got cut out because of the size problem. So here you can see operation, decomposition, how the flowing of process is happening. So E1, E2, M1, M2, up EOP calculation, significant shifter, binary adder, come subtractor, shift calculator, normalization, adjacent. So here's how the flow diagram of the transition level internal diagram, which was provided in the paper itself. So adder and subtractor and multiplier. So this is how the first one is for adder and subtractor. So this is how it works. These are the links and graphs. This is for multiplier. Uh, so the first one is for adder and subtractor. The second one is for multiplier. So let's get to the sixth question. Compare the proposed architecture with existing architecture in your reference book. Okay. So comparison of architecture. The paper proposes implementation of IEEE 14-point multiplication, addition and subtraction arithmetic on IEEE FP number imposes more challenges compared to fixed point arithmetic. These practically include the simultaneous computation of normalization and rounding. We show the efficient way of solving these challenges for implementation of floating point addition, subtraction and multiplication. The proposed design aim at reducing power dissipation. Here, main threshold multi-threshold voltage technique is used for reducing power dissipation. The proposed implementation are according to the IEEE 754 FP standards. So from the above we can see we can compare it. So for the seventh question, list the advantages of the proposed design over existing design. So so let me propose the proposed system consumes very less power than existing model. So here, as per the question, we are trying to decrease implement low power floating point arithmetic unit, so it consumes very much less power than existing models. The paper shows an efficient way of solving these challenges for the implementation of floating point addition, subtraction, and multiplication. A multi-threshold voltage technique is used for reducing power dissipation. The low power optimization technique multi-VT is used for reducing the power consumption of arithmetic unit. The built-in libraries like typical, slow fast typical, and slow typical fast slow high volt are used in design for optimization. So for the eighth question, list the merits and demerits of the proposed and existing techniques of hardware. Merits: in the multiplication threshold voltage techniques, both low volt and high volt cells are used. Here on the critical path, threshold gates are used while higher threshold gates are used off the critical path. The method improves performance within an increase in the power, and trade-offs maintained between the different VT cells for optimization performance are beneficial during synthesis, technology, gate mapping, and placement optimization. The synthesis tools does the logical synthesis of gate mapping, and physical implementation tool does the placement optimization during the physical synthesis. The implement multi-threshold optimization algorithm is capable of optimizing several VT levels at the same time. So the design is optimized using the higher threshold voltage library initially, then for the next lower threshold voltage library. Multi-volt optimization computes the power performance trade-off curve up the maximum allowable leakage power limit. So subsequently, for switching the most critical gate to the next equivalent lower voltage version, the optimization starts from the most critical slack end of this power performance curve. This increases the power leakage in design beyond the maximum presumable limit. So the demerits of the floating point achieves this by keeping the relative error constant. So that is the number will start to be round after a fixed number of decimals. This is simplification but helps to understand the principle. This is very similar to the concept of significant figures from the most natural sciences. However, this means the floating point numbers are always somehow rounded. If you add a few small numbers to a very big number, the small number will just be tranced and the big number will stay. This happens when the small number is below the threshold. If you add many numbers, it might sometimes be necessary to sort them first and add the small one before, so the big one. This is also the concept of numerical stability to consider, that is how an arithmetic will draft off the correct results due to rounding. Let's get to the question number 9. Question number 9, list the application of proposed design. Okay, the list of the application of proposed design. Traditional computer data processing is limited by computer data input, output, storage, display. Further computing needs repeated binary decimal conversions. With the expression of data intensive computing need for distributing power, decimal computing of max data is widely applied in banking, financial, signal processing, biomedical, astronomy, geography, and also image compression and other fields. Independent decimal floating point is unit is becoming important in these areas. A floating point is a part of computer system specifically designed to carry out operations on floating point numbers. Floating point unit has been implemented as a coprocessor rather than an integrated unit in various systems. Today's floating point arithmetic operations are very important in the design of digital signal processing and application specific systems. In the most of the digital signal processing applications, addition and multiplication is done frequently. So for the 10th question, draw the flowchart of algorithm or transition level circuit proposed in the design in encapsulated file format. So here uh, this diagram also you can draw using Microsoft Visco. So Microsoft Visco, or you can also use the tool that I was previously showing. Create a document, blank document is created. So now you can either use Creately or you can also use Microsoft Visco, so which is very friendly with drawing flow diagrams which are very lengthy. So there you can choose whichever component you want. You can use different types of shapes in Visco. So let me show you how you can take rhombus and other. So here you can draw a square, an ellipse, circle, and rectangle, and using the same as we shown in previously in this. Okay, like this, like so. By that you can easily draw this, and you can download it later in the given format. So the given file you can always download in PNG format, and the references are by R. Dunball. So design and implementation of low power floating point arithmetic unit, 2013 International Conference on Clean Computing, Communication and Conservation of Energy. ResearchGate uploaded by Dunball R on 16 September 2015.